We're going to go ahead and get started. Welcome to today's CNCF webinar, Automating Kubernetes Deployments. I'm Chris Short, CNCF Ambassador and Principal Product Marketing Manager at Red Hat. Work on the Ansible team there. I'd like to thank everyone who is joining us today. We would like to welcome our presenter, William Shia, Senior Product Marketing Manager at GitLab. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there. We'll get to as many as we can at the end. I will also be monitoring the general chat, so if there's questions there, feel free to mention them there as well. The session is being recorded and will be sent out afterwards, along with a link to the presentation. Again, if you have any questions, please feel free to ask in the Q&A box. With that, I'll hand it over to William to kick off today's presentation.
Hey, thanks a lot, Chris. As Chris said, my name's William Shia. I am at GitLab, and I get to work on a lot of the functionality on the operations side of GitLab. So I am very happy to chat with all of you today about automating Kubernetes deployments. And my Twitter handle's on the screen. Please feel free to shoot me a message on Twitter, keep this conversation going even after this webinar. And while things are going, please do type in questions and comments in chat. And if I don't get a chance to address them as we're going along, then we'll definitely do some Q&A afterwards. So just kind of to map out what I'd like to talk about today, basically in 3 sections, I wanted to briefly go over what is GitLab and why, kind of the viewpoint that we have as, I'm talking here about automating and scaling deployments, doing continuous integration and continuous delivery, what our viewpoint is and where we're coming from, and then do a demo and then the code. And the reason is that often you'll go to an engineering focused talk and they'll show a bunch of code and then they'll show you what the code does. But in this case, I think that showing the demo first and spending the majority of the time showing you what everything does will actually inform how all of the code works. So then when we actually go to dig into the code and what the code is doing, it'll make sense in that context. So in brief, that's kind of the outline. And the bit of a theme or a flavor I'd like to overlay on top of that is the concept of composable building blocks, or sometimes here at GitLab, we use the term small primitives. And so just like APIs or building with Legos, the engineering concept of building a small composable element and then being able to use that to build other bigger, more complex things is something that I'm a big fan of, and that I'd like to interweave in how that plays in how we're talking about continuous delivery. So this is a CNCF Cloud Native Trail Map. So I've put the link here, and what I'll do is throughout this presentation, I'll have a GitLab repo, and I'll share the URL for that repo, and all of the links that I have and a link to my presentation will be in that repo. I'll put that all in before the end of the talk. But here you can look at, as you're an organization, you're looking to adopt cloud native. It might start with containerization just at a basic level, and then moving into CI/CD, container orchestration, observability, et cetera, as you move down. And so this is where most of the focus I want to zoom in today on this idea of continuous integration and continuous delivery, and how we think about that and how to do that really CI/CD as code, again, as building blocks, and how some of the benefits you can get out of that. And the way I look at it like this is realize that there is a broad diversity of folks on the call. Many folks may be contributors to Kubernetes and other CNCF projects, and some folks may not be familiar at all. So at a basic level, the way I think about Kubernetes is that you can have whatever infrastructure you want. So whether that's a bare metal server or on any type of cloud platform, and Kubernetes is an abstraction layer on top of that that does all of your container scheduling, all of your orchestration, it manages scaling. And so you don't have to really think about that underlying infrastructure, or it allows you to have this great portability where you have a cluster on AWS or a cluster on IBM Cloud or on bare metal, and it just behaves the same way. So when you build on top of Kubernetes, you get this wonderful abstraction layer that allows you to move a lot faster. And so, of course, in addition to some infrastructure, in addition to Kubernetes, what do you actually need? Well, you still need some type of DevOps tool chain. So, of course, you need some type of source code management. But in addition to that, you usually need some type of project management or issue tracker to say, this is the work we're going to go do, and then go and write that code. Of course, core to deploying software is having a way to test and to deploy that software. And then you also need, as you kind of saw on that trail map, some type of package management solution. So if you're doing continuous delivery or continuous deployment, you are going to need some type of container registry to go and store all of your containers, and some type of artifact repository so that you can pass your build artifacts between different states of your CI pipeline. Of course, you are going to want to do some type of application security testing to make sure your app is secured. And then once that is deployed and in production, you want to do some monitoring. This is a great simplification. I think that the tool chain could get broad, but I just wanted to show this because I think that most folks that are familiar with GitLab, this kind of comes down to what is GitLab. Most folks that are familiar with GitLab know that GitLab does source code management. So it handles your version control, it's your Git repos. But what folks may not know is we also have a really, really robust CI/CD, which is what I want to focus in today. And the way that CI/CD is informed is, in fact, not only do we have source code management and CI/CD, but GitLab is actually a single tool that actually does all of these things. We call it a single DevOps tool, and you can drop the chain. In fact, we have this graphic on our homepage that shows these are all the things that we have shipped. Our functionality has grown and grown and grown. So we started out just as source code management in 2011, and then had this massive accelerated pace, and there's even more on the roadmap. The idea is, like, how did you get such a big product, and how did that grow so fast? Well, the way that we did that is through a very, very high velocity of development, and I attribute that to being open core. So GitLab is an open core. It means that our core product is open source. We have over 2,200 contributors to that open source project. And in fact, Dan Cohn, he did like a blog post here. I've linked it. I'll link it in the notes, that talked about the top 30 highest velocity open source projects. And GitLab was one of those projects. So by being an open source project, we have many, many folks contribute. And even our paying customers, we share the code of the paid product with them, and they actually even contribute back to the project. So that is how we've been able to, at this high pace of velocity, ship so much functionality and have this product that spans what we call the whole DevOps lifecycle. So I share that as a bit of background to say, as I'm going through the demo, this is our perspective, our viewpoint, is that when all of these things that are single application, when your pipelines are together with your code and your issue tracker and your monitoring, there are some nice interplays, and maybe I'll show some of those as well. So with that, I really would just like to jump in to a demo. So before I do that, I will ask a question. I'll see if any folks are hanging out in the chat. What I'd like to do is I'd like to set up right now a CI/CD pipeline. And so my question to the folks in chat is, starting from scratch, how long on average does it take you to build a CI/CD pipeline? And so I wonder if folks will be brave, if anyone's going to weigh in. Someone says maybe a half hour, couple hours, an hour, depending on the requirements. It looks like we have a couple. So build, test, deploy, less than 5 minutes, using some different tools. So one line and a YAML commit. So this is really good. It seems like there is a wide variety of experiences here, and I would continue folks to maybe continue to drop in some chat or to share a story about why it takes you less or more time. There's a wide degree of variance. What we've seen is, in order to build a really robust pipeline, it can take some time. So to spin up something quickly, maybe you can get it going in a few minutes or an hour, but to get something robust takes longer. So what I'm going to do is I'm going to build a pipeline now, and hopefully I can do it very, very quickly. So what I'm going to do is I'm going to start a new project in GitLab. and I'm going to create it just from a template. So I'm just going to use this Node.js template. And so the reason I'm doing this, I'm going to call this one CNCF demo. And I'm going to create this project. And the reason I'm starting from scratch is just basically to show I haven't done anything before. This is, you're literally seeing it's going to import this progress. And the one thing I'm going to do before I walk through the code is I am going to add a Kubernetes cluster to GitLab. So let's go over to Kubernetes. And I'm going to add a cluster. And what's nice is I can add an existing cluster, any type of cluster at all, as long as it's what's called upstream Kubernetes. And the vast majority of cloud providers support these. But we do have some really nice integration with GKE. And so what that allows me to do is basically to create a cluster. So when one does not exist, I'll call this one the demo. My environment scope is going to be this. I could have different environments in GitLab. So I might have a staging environment and a prod environment, or there might be different reasons. An asterisk is just going to say, use this cluster for everything. It's integrated with GKE, so it knows I already have a demo project there. And I'm just going to leave the zone and machines default, enable RBAC, and create my cluster. So this usually takes, I don't know, about 5 minutes to spin up a Kubernetes cluster. So this is the viewpoint here is if I'm just starting from scratch, of course, something went wrong and it failed. Let's just see for a moment.
Yes, the live demo gods have struck again.
Now, what I will do is I will do a little bit of live troubleshooting just to make sure, because I find that is the way to go. But when it comes to the demo gods, I call myself an atheist. So what
I respect that. However, they don't.
I've prepared most of this in another project, but if I can get this to go through, I will give it a shot. So it seems that something perhaps is not right there. So let me give that one more shot. What I'm going to do is I'm going to remove this integration. And let's go ahead and add a cluster. We'll just give this one CNCF demo for real. I will call that one. And just to use a name I haven't used before. So let's go ahead and give that a shot and see if that cluster will go through. We can look over here in my cloud platform dashboard and see if it begins to create that cluster. I am now wondering if I signed in with the wrong credentials. That's all right. As I mentioned, I do have a project spun up for just such an occasion. So what I will do is, let me just go really quick. I am going to show what's in this project. So if we look at, this is a really basic Node app. So I suspect there's some auth problems with creating the cluster, but really basic Node app based on Express. So there's an app.js, and you can see this is really bare bones, simple Express app, nothing very fancy here. There are some views. And so here is an index layer where it's going to take in a variable and make that the title and make that a welcome. And there are some routes. And so I can see in the route, it's going to, at the index level, it's going to pass in the title Express. And so what I can do is I can show another project where I happen to have made a merge request. And so the first thing I want to show is that with just this type of project, and actually maybe I'll even show that first, that this is the same project. You can see there's nothing fancy in here. There's no GitLab CI YAML. There's no Docker file. This is the same project. And what I've done is I've enabled a Kubernetes cluster, and I can show you that over here. And so here is where I've connected that cluster. And then I've enabled what we call auto DevOps. And the way I think about this is DevOps is about automating things that would normally be manual. And so you would have all of these scripts, all of these testing scripts, and all these deployment scripts. And when you start to automate those, that's a key tenet of DevOps. But what if you even automated the automation? And so then you get auto DevOps, where you just get pipelines out of the box. So there's no YAML file in here. There's no pipeline defined. But if I go over to my list of pipelines, I can see that I've already got a few that have run on this project. And so looking at this is the commit, and I can look at this pipeline. So just by enabling auto DevOps, it automatically enables a pipeline for me. It has a couple stages in here, a build stage, test, production, and performance. And what I can do is I can click into each of these to see that process running. So as it builds, it can show me what the runner is actually executing. And so in order to explain this a little bit further, I'll pop over to the slides just for a moment. And I want to talk about the GitLab runner and the architecture, so that as I'm describing the pipeline and how it's deploying into the cluster, it'll make a little bit sense of how it works. So the CI/CD architecture for GitLab is that your main GitLab instance is where your pipeline is defined. This could be either in a YAML file, which I'll show a little bit later on, or as I mentioned, via auto DevOps, where I simply enable that, or it's enabled by default. When I add a cluster, it automatically builds a pipeline for me. And then the executor, or the agent, is what we call GitLab runner. And so GitLab runner is a separate project. It's a Go binary, and that's going to pick off various jobs in the pipeline. So you can see that this is a build job, and this is being executed by the runner. So what's nice about this is you can have multiple jobs executing in parallel, and another runner can then just pick up the job. So because it's a Go binary, it means you can install it on any platform, Linux, Mac, Windows, or basically anywhere that will compile a Go binary, or anywhere that supports Docker, you can run a GitLab runner. So you can have multiple runners, and they can go and pick up jobs. But the other nice thing about this architecture is that runners can be auto-scaling. And so by using auto scaling, and this uses Docker machine, so any cloud platform or any system that you would build that uses Docker machine, you could even do this with anywhere that uses Docker machine, you could have essentially a bastion runner that will then spin up additional runners to pick up more jobs. So for example, we know a lot of organizations, everybody does their bi-weekly sprint, and then the Thursday before Friday, when they need to do their sprint demos, everybody commits their code at 4 o'clock on a Thursday and wants that to run through CI. So that auto-scaling runner can just spin up a ton of runners to take care of all those jobs so that nobody's waiting in a queue. But even better than having one runner that spins up additional VMs, say on DigitalOcean, is our Kubernetes executor. And so when you install a GitLab runner inside your Kubernetes cluster, and you can use a Helm chart to do that, that GitLab runner is an auto-scaling runner that will just add more pods to your cluster. So you get that same amount of auto-scaling nicely out of the box. And then when there's no more jobs to execute, they scale down to save on cost. So this is the architecture that is in the runner. So maybe the pipeline makes a little bit more sense. When it kicks off this test phase, it'll kick off, both the code quality and the test. And what this test is going to run is it's going to run what is in my test folder. And I wonder if I can just go to this commit to show that for a moment. Where, yes, okay. Package. So in this test.js, you can see that inside the test folder, it just has a really, really simple test defined. It's going to make a request out to the app. It's going to get that root path, and it's going to expect it to say, welcome to Express, which, as I showed in the index layout, it says, welcome to Express. And I would say, let's say we want to update that, and I don't want it to just say, welcome to Express. I want it to say something a little bit different. So I've created a merge request here to have a more friendly welcome. And we'll just take a look at the changes here. And essentially what I want to say, I want to make the title of this page the CNCF webinar. And I want it to say, hey, wonderful people that have joined me on the webinar today, welcome to the CNCF webinar. And in addition to this, if I just made that change, then my test is going to fail. So I no longer want to check for the body to be welcome to Express, but I'm just going to expect a 200 OK. And this is using Mocha, but of course for JavaScript, but you could use any type of testing framework. And so what I showed you here is just taking a look at these pipelines. So what I showed you here coming out of the box is a production pipeline. It's build, test, deploys to production, and then on that running production instance, it runs some performance analysis. But when I create a merge request in GitLab, and a merge request is the exact same thing as a pull request. We just call it a merge request because you're making a request to merge. You get a few additional stages. So let's take a look at this merge request pipeline. And what this is going to have, it's going to have the build, the test, and this review stage. So there's a couple of different differences. So one is review. It has DAST in front of performance and a cleanup stage. So the main differences are this review stage is going to, for this change, it's going to, because it's connected to Kubernetes, it's going to spin up an environment just for this merge request. So for this one branch, it's going to have its own environment in Kubernetes, and it's going to spin up a review app so that I can review those changes. And I'll show that in just a moment. The other thing is you'll notice that a bunch of additional tests. So what I did is I went and made this project public. And with GitLab, we, as an open source project, as open core, we want to support other open source projects. So on GitLab.com, we allow any open source project to have all of the features of our top tier for free. So I'm showing now there are some features in GitLab's open source project that you can download and install or use a free plan on GitLab.com. And there are some features that are part of our paid product. But if you have an open source project and you're on GitLab.com, you just get those for free anyway. And so a lot of those include automatic, say, container scanning, dependency scanning, license management, static application security testing. Then it deploys in the review environment. Then it runs a dynamic application security test on that running environment. So all of the security functionality is, again, I haven't defined a pipeline. I haven't done anything yet. I just made a merge request, and here is the pipeline that it pulls up. So what that looks like is, let's take a couple different views of this. So one is I'll go over to my environments tab. And here you can see I've got two different environments running. So here's my production environment. It has one instance, and so it means I just have one pod scheduled in my Kubernetes cluster. And I can look at this pod, and these are the pod logs within Kubernetes. And so if there was something funky or I had a bunch of instances, I could click into those. And what I can do is I can go and open that live environment. So here it is. This is my production environment. It's got this old generic message that I don't like very much. But in my merge request, I've got this review environment. And so it spun this just up for that merge request, and I can go in and look at that review environment. So here it says, hey, you wonderful people, welcome to the CNCF webinar. So this is not just showing a web change, but because it's an entire environment, it means you can test the differences between anything at all in your code or deployment process. So this type of model of continuous delivery is something that we think is really, really powerful. And it's something that Kubernetes enables. And it's why we at GitLab have engineered this tight coupling so that the pipelines just work with Kubernetes. This is something, again, this kind of what we call this auto DevOps experience. You can use GitLab with anything. You can deploy to bare metal if you want. But when you're deploying to Kubernetes, when you connect to Kubernetes cluster, this is the experience. So what happens is if I go ahead and I'll show one other thing. So one thing that's really nice is in this merge request, we think of this as the developer's view of the world. So this is, of course, going to show any changes in the code, where if I was doing code review for a colleague, I would go look at this and I could add a comment, you know, looks good. And I could see any discussion. But additionally, we think it's really, really important that teams are able to collaborate and that developers also get the view of the pipeline. So right here, they can click in, and if anything is blocking, they can just go and look at those logs as well and have that jumping off point to see each of those states. Additionally, by surfacing these types of tests, so for example, let's say this security scanning. So we can see here that our container scanner, it detected quite a few vulnerabilities. So my security team may not like that, or it might block my deploy. So in order to move faster, we want to shift left, and we want to just show that vulnerability right in the merge request with the code, because the developer is going to be able to see, oh, by adding this, I've now added these vulnerabilities. And this is something that either the security team or the developer could resolve, but they can click in, they can look at the CVE, and then they can either decide, I want to dismiss this, I've accepted this vulnerability, or I can see, you know, if I upgrade my container to a better version or a more recent version of Ubuntu, that is something I really want to do. So I'm going to go ahead and create an issue to remind me that I need to do that later. So this isn't going to be a blocking security vulnerability, but this is something that I want to get done, and I can assign it to people. And so this is where I was saying earlier, thinking about this idea of, I like that Adam says, to-do security. This idea of having everything integrated in one tool, having your security tool showing the same place or showing the same view from the merge request, being able to create an issue to remediate that later on. This is why we've put all of these things into a single application instead of having to have folks integrate with all of these other points. So in addition to getting Kubernetes and all the value out of that, you get this functionality all together. So this looks good to me. I'm going to go ahead and merge this merge request. And what that's going to do is it's now going to kick off another pipeline. So this is going to kick off a production pipeline. And I can watch this one running live. So you can see that it is going to go and in the build state. And what it's doing is it's going to go and pull an image. And if it's in my registry, it'll pull it if I can do caching. But here it is. It's essentially running this setup Docker script and a build script, which I can show you in just a bit. But this is really a shell-based executor. So anything that you can script, you can execute as a pipeline job. And so this is going to run my build, and it's going to go through and run those additional tests as it goes off and deploys to production. So we'll let that pipeline chug on for for a little bit, and we'll let that one go. And what I do want to show is, what does this look like if I actually use code to go do this? So everything I've shown up to this point, the only thing to make that happen is literally to add some code and make a merge request. Add some code, add a Kubernetes cluster, and make a merge request. So I basically just commit my code, and GitLab has created a pipeline for me. It's added all the security testing. It's even picked up some basic tests, and it's created a review environment. All this is done for me. But this is not just magic under the covers. This is actually all nicely defined in a YAML file. And I can show you what that looks like. So the way that Auto DevOps, the functionality works is there's no Docker container in here, but as the script is running, it will try to detect what language this is. So it figures out, oh, this is a Node app, so it's going to use a Node container and some other things. If I have a Docker file, it will just use that Docker file and do everything else automatically, right? The same thing with a CI YAML file. If there's a CI YAML file, Auto DevOps will use that YAML file first and then implement the rest of the functionality. So I'm going to actually show you what that code looks like. So I'm going to add a new file to this directory. And this is the value of defining pipelines as code. So as I mentioned, I showed you the demo first. You see everything that's done. All of that was done via this YAML definition. So you can see that you can choose several different types of CI templates, but I'm going to use the Auto DevOps template, and we're going to go ahead and commit this, add Auto DevOps template, and I'll make it in a new branch. And that will open up a new merge request to use the Auto DevOps template. And it will kick off this pipeline. And now this pipeline that's running in this merge request is actually running off of this file that I just committed. It's not running off of the Auto DevOps, but it's the exact same thing. So let's go ahead and take a look at this file and see what's actually happening and unpack what's inside of a robustly defined GitLab CI YAML file. So you can see at first glance that this is about 1,000 lines. So not a lot, but it's not skimpy either. And so what all that this Auto DevOps functionality is, where I can just start off and I can commit my code and everything just starts running for me, is just a nicely defined YAML file. And I saw some other folks that are already experiencing this type of CI/CD pipeline say that it takes me 5 minutes. I pop in my YAML file and I go, because it's defined as a template. So I'll walk through some of what the syntax is and how these things are built. And then we can look at some other ways that you can use these as composable building blocks. So to start out, an image is literally just going to be a container image. So as a base, if no other image is defined, it's going to use Alpine Linux, which is just a very, very small svelte version of Linux. I think it's like 5 megabytes. So there might be a different image defined, but that's just going to be the base image. And then I'm going to define some variables. And you'll notice here that, again, this Auto DevOps template is designed to just get you up and going really, really fast. So you can connect that Kubernetes cluster and just be up and going. But you may want to do some things differently. So for example, you may want a different Postgres password. You may want to use that as what we call a secret variable. So if I go here to settings and CI/CD, I can define some environment variables, and I can make sure that they are protected. And so anything that I want to pass in as credentials, this is a better spot for them. Of course, you need to input these manually, as opposed to having them in configuration. But there's a few other ways to do it. You could have it in a separate part of your configuration. and then port them in. And then you can also, we just released this feature where we call it a Kubernetes secret. This would be is if I need to pass credentials into something that's running inside my cluster. So perhaps a service. Maybe I've integrated with some type of service, like let's say Twilio, and I need my API key. But my application running in Kubernetes needs access to that. I could use this Kubernetes secret. So after defining some variables, then I am going to build out the stages. And so you can see that these stages map to what you've seen in this pipeline with the build, test, review, DAST, etc. But there are some additional files that or some additional stages in the file that we didn't use yet. So maybe I'll get to use these before we're up on time. But you can see there's a canary, there's an incremental rollout, and then performance and cleanup. So first you define the stage, and then you define jobs. And so this is the job name. Now this can be any arbitrary name that I want. In this case, I've named the job the same thing as the stage. And we can see in the build stage, there's only one build job. And so that's why the stage defined for this job is build. In the test stage, there is a test job, but you could also see, like, for example, the code quality job is in the test stage. We can also define here a Docker image to run that job in, Docker services. And so for GitLab, a service is essentially a separate image that I want that can talk to my initial image without me having to build everything manually. So a really good reason to do this would be is if I wanted a database available, let's say Postgres, I could just add Postgres as a service. That way I don't need to build it from scratch in that step. In case this one is using Docker and Docker. So that's what's running the build stage is Docker and Docker. And then these scripts, and these are literally shell scripts as you saw earlier. And you could see it running, for example, in the build stage. It is executing this setup Docker. And then here is where that script is defined. And so in this file, inside of the job, I've just made it a very simple script. Now I could add, anything, you can see this is literally bash commands, or I can have it a bit more sophisticated and organize it where I have this Docker setup script, and we can look lower in the file that that's actually a function. And so instead of having to write out all of this little bash script each time, I defined it as a function later on in my file, and now I'm able to call it from within various jobs. So a script is literally any type of bash scripting, and then I can even define it as a function and reuse it to do code reuse. And then we have a keyword only or except. This means it's only going to run on branches. If I kick off a pipeline via API call, it's not going to run. It'll only run on branches, things like that. And then this one is interesting, and let's see if we can make use of this here, is the idea that don't run this if this variable is defined. And so I can say only run on these certain set of conditions. This could be maybe I have a microservices architecture and I have a mono repo where all of my code for all of my different microservices is in one Git project. And then each folder might be a different microservice. So I might say only run this job on this specific folder. If this folder updates, go and run this job. Otherwise, don't run it. So that way, when I update one microservice in a mono repo, I'm not building everything all over again. In the same way, I can say, don't run this with an except clause. So those are the basic stages there. Artifacts, for example, with code quality. I talked about having an artifact. So for example, here is the GitLab registry, which will take any containers and just store them here in the GitLab container registry. And I can also look at a particular job. Let's look at one that has already passed. And here I have an artifact browser where I can download or I can browse this code quality artifact. And I can look at this JSON report and see what it says. In this case, it looks like everything is pretty solid. So if I wanted to keep this artifact, it's available for that job, and I can make any type of artifact available or pass it on to the next stage of my pipeline by using the artifact keyword. And these are most of the stages that are defined. I want to show off one last thing in the file and then show off a way that we can compose them before we jump into Q&A. So the other thing that we have defined is in GitLab, we use the syntax of a period or a dot to create what we call a hidden job in our CI pipeline. And so all this means is I'm defining a job, but it's never going to execute. So I'm basically just using this as a template so that I can put it into another job that does execute. Again, coming down to this idea of reusable, composable blocks, I can build a set of scripts. And in this case, I have this production script where it does a lot of things. And I know I'm going to want to do this a few times. So then I can use, this is a YAML functionality or a bit of YAML syntax called an anchor. And so I'm using the GitLab hidden job and a YAML anchor. And with that YAML anchor, it allows me to put that, so all of this essentially just gets injected here, and then I can run my only and accept. So that allows me to do a production deploy, just continuous delivery, or continuous deployment, sorry. And then it also lets me to say, okay, I want to do manual. So this one has a when manual, which means I need to click a button in order for it to go. So with these small primitives, stages, jobs, and templates, this type of templating, you can really build something very sophisticated. And you can see that you could take this file, it has a lot of stuff in there, and now you can start to build it out or compose it the way you want. So the last thing I wanted to show, and I don't quite have time to walk all the way through it step by step. So in this case, I'm glad that I am a demo gods atheist and I did this ahead of time. What I said is I want to use an include. So one of the things that you can do is you can take a CI/YAML file from one project and you can include it in another project. There's a lot of use cases for this. You may want your operations team to actually manage that file and have individual product teams put it into their service, and then they can add additional things, but you have some type of master that's managed by an outside team. But essentially what I've done in this project is I created a new project, and instead of Node, I think this time I created a Spring app. Or no, I'm sorry, this is a Ruby app. So completely different language. I just imported this as a Ruby app, and I added a GitLab CI YAML file, but all this does is it uses this include clause, and it says, hey, go over to this other project and suck in that GitLab CI YAML file. And then I want to set a few different variables here. So first, I want to bump up the replicas to 10. So instead of 1 pod, I want to have 10 pods that are running, maybe for greater scale. And instead of just continuous deployment to production, I want to do a manual incremental rollout. I'm going to go ahead and disable code quality because I find that it runs a lot and I don't need it on this repo. And then the only thing different is this project is using a different cluster and a different domain name. So by importing that and setting a few variables, I'm using the exact same YAML file on a completely different language. And I can look at the pipelines here where I have merged that. And here is now my production pipeline, where in this case, it omitted the code quality, but it did the rest of my security testing. It ran the build, and now it's waiting to roll this out. And so if I look at my environments, I can see that I haven't deployed anything to production yet. But here are my 10 instances in the review app. And so let's go ahead and roll this out to 10%. And we can watch that as it goes. So here is it's pulling my Docker image. There you can see it was that Alpine image to kick things off with. And then it's going to check out the hash. And now it is using these Helm charts. While this runs off, I do want to show one other link that we do a lot of things with Helm charts. So something I didn't quite show, but is being able to one-click install different applications, things like Helm Tiller and Ingress and the Cert Manager. And we do that via Helm charts. So I can, while this builds, I can actually show that in the, so here inside the Kubernetes cluster, when you add a cluster, what it does is it lets you just click to install these things. Now, if you're running this in production, you're probably going to manage this all yourself anyway. But the idea is to abstract this for the beginner, make it really easy. So just go ahead and install Helm, install Ingress, install the Cert Manager, install Prometheus. And we, of course, do that all via Helm charts, which are in this, and I'll share this doc. And so we can see that that job succeeded. So I should now be able to go to environments, although the pipeline is still running. But here I have one instance. It's rolled out to 10%. I can go and look at these logs. I can say, you know, this looks solid. I can go and test that, open up the live environment. It probably is 404 for me for some reason. Let's just take a look at monitoring. It's waiting for that data there. But let's go ahead and kick that out to, let's say, 50%. And it's going to do a rollout. So inside of this pipeline. So that is an example. Here is some of these metrics that are coming out of Prometheus now. This is an example of taking the same exact YAML file, you know, in the pipeline. Now I'm rolling out to 50%, and it's a manual rollout, and it's on a Ruby versus on a Node. So with all of that, I will just show a few more slides. So what I've kind of showed you today is some basic building blocks. If you have a few Legos, you can build something really simple, get up and started pretty darn fast, and start to customize it. Of course, with these primitives and composable building blocks, you can then build something really sophisticated. And someone who has done that is the CNCF CI working group. And so if you've seen this dashboard, it's pretty impressive. And it is running on GitLab for the CI. So this is a really complex thing where this working group said, hey, we want to run cross-project, cross-cloud. So I want to see how Kubernetes, Prometheus, CoreDNS, Linkerd, Envoy, et cetera, perform on AWS and Azure and GCP and IBM Cloud and OpenStack. And I can go and look at any of these jobs. So here, this one was successful. And this is their instance of GitLab, which is a similar interface to what I've just been showing you, where you can review that job. You can browse the artifacts for that job. And so this is something that's a bit more complex that is built out of those primitives. So with that, I'll leave you with, hey, what's coming next? In addition to being an open source company, we also do a lot of things publicly. So we keep all of our issue trackers public, and all of our vision and roadmap are public. So as I mentioned, I'll share these links. And here you can basically go in and see what are we building, what's coming up in future releases, what is the vision for CI, and what is the vision for CD. And what I will do out of all of my many tabs is I will get to this CNCF demo one, and I am going to edit the README, maybe. And while I do this, perhaps Chris, we can.
Yes. Sure. Would you like to do some Q&A now?
Yeah.
Yes. So just to clarify something, everything you're showing is available in the paid and unpaid open source version of GitLab, or?
Yeah. So that is a great question. What I will do is I'm going to commit these changes here. So there is a, there's a page on our pricing page. So if you go to about.gitlab.com, and for example, there's a link here that says see all features. And this will show you a comparison of what's in the free tier and what specific features are in various tiers. So I just went ahead and showed the top tier. And my rationale for that was that if you are an open source project, you can just go ahead and have a public project. So any of these features that you want to test, you can just create a public project and get access to all those features. And if you want to see which ones are available and what it's on that pricing page, which I'll add now.
Awesome, thank you.
Yeah, no, it's a great question.
Let's see. Does GitLab come with tools, processes, policies, etc., to control resources, like resources in the sense of monitoring systems, shutting them off, things like that?
Yeah, so I focus more on the delivery and deployment, but what we do is we do bundle in Prometheus. And so you can use Prometheus monitoring to essentially look at a lot of those things. If I can pull up a dashboard in a moment, I want to add this link to my repo here. So I'm going to start shutting down some stuff and I'll add some more links. But
cool.
But yeah, system monitoring today, I would say you can also check out the configuration and release roadmap to kind of see what we have coming in that direction.
Cool. Do you provide any integration or steps to integrate with some kind of secret management, like Mozilla SOPs, Bitnami sealed secrets, HashiCorp Vault, etc.?
Vault, etc. So we do have a robust API, and we have lots of folks that integrate with Vault and some of those other projects. So today we don't have a built-in integration in the way that Kubernetes is integrated, but folks do use those projects via our APIs.
Awesome. As far as security scanning goes, what kind of data sources are used in that? What is the security scanning look like there?
So that is a huge question. There's a lot. You can see that there was, so kind of talking about those primitives, each one of those things. So SAST is like its own set of security application testing. And at the high level, there was a security company named Gymnasium, and we felt that Gymnasium was really doing the best at dependency tree graphing. And so the idea here is I have a project and I've NPM imported a module, and that imports a module, that imports a module. The dependency tree goes really, really deep, and 7 levels deep, there's a vulnerability I didn't know about. Mm-hmm. So Gymnasium had this really great dependency tree resolution. We acquired that company and ported that Gymnasium feature, and that started our security team. Since then, we've built a ton of security functionality, and a great way to get to all of that stuff, because of course, not only is the code open source, but the roadmap and such. So you can see, for example, here are links on the homepage in this graphic I showed, but if you click on this coming soon, you can see this is the direction for GitLab Secure, what categories we have, what we shipped, and that's a launching off point to see the different bits of functionality. So for example, just quickly, static application security testing is I'm going to scan the code itself and see if there are patterns in there that are known to cause vulnerabilities. Dynamic application security testing is I'm going to deploy that into an environment and scan that running code, right? Dependency scanning is I'm going to look at that tree and say, okay, you have a security module 7 layers deep that has a vulnerability. License management would be, what open source licenses do I have? There's some more here. Some of these, like fuzzing I asked, are on the roadmap, but I will add this link into my repository.
Let's see, there's still a lot of questions left. So let's see, as far as container registries go, can you bring your own container registry?
You can bring your own container registry. So you can use Docker Hub, or you could use any container registry you want. In fact, a lot of folks integrate GitLab with other things. So for example, if you wanted to use something else as your code repository, let's say Bitbucket or GitHub, or even just your own Git running on a server, and you then wanted to use GitLab CI/CD, you could use most of the things that I showed today, certainly the CI/CD, and just have your Git somewhere else. So what's nice with the GitLab registry is it's all integrated and it automatically does the things for you, but you could certainly bring your own registry if you wanted to.
Great. What about environment variables? Can you specify those variables as part of the code base itself as like JSON?
Yes. So obviously, don't recommend having environment variables in the code, right? Don't commit secrets to your code. But there are a few different ways to do this. So essentially, you could have a secrets file in a private repo that's not accessible publicly and whatnot, and then import that in or suck that in. That would be one way to do it. Or you could add secrets into GitLab, and those secret variables then don't show up in your logs. And there's some other things that we really recommend using that system.
Sounds great. Let's see. So there's, sorry, let me mark that as red. Does Auto DevOps provide me with a generated YAML file?
So the Auto DevOps, not per se, but it is essentially what it's doing is it's running that file that I showed. So the way to get to that file, and maybe I will even link that in here. In the repo, you can actually see it in the repo. And it's literally a, so this, I will link my other repo, which also has the file. So let me do this. So these are my other repos. But yeah, it's literally, it's just a template. And if you go to add a new file, as you saw earlier in the webinar, and add a file from the template, you can just choose that Auto DevOps template. So that is, it's not generating that, it's the other way around. That's all specified in the YAML file, and Auto DevOps is sucking it in.
Okay. Let's see, multi-cluster support. Talk to me about if I have a dev cluster, stage cluster, prod cluster, how do I integrate with that?
Yeah, absolutely. So that's a really good question. There's a couple ways to do that. So I'm showing you at the project level attaching a project to a cluster, but we also have group level clusters. So this, you would create a GitLab group, and that would have many projects underneath it. And then each of those projects could deploy into that cluster. So you might allow most of your projects to deploy into your, let's say, stage cluster, your dev cluster, but only a particular release team has the access to deploy into the prod cluster. So those could be managed at the group level. That's what I recommend. But what you can also see is that at a project level, I can just add another cluster. And I believe this is a paid feature. But again, if you have a public project, any open source, it just gets access to this. And you can just add multiple clusters to each project.
Nice. Awesome. Well, thank you so much today, William, for your great presentation. We appreciate everyone joining us today, and we look forward to seeing you again soon. I'm sorry, I normally would tell you when the next one is, but I don't have the details on that yet. So see you again soon, and have a great day.
Hey, thanks a lot, Chris. Really enjoyed everyone on the call. The URL here, William Chia CNCF demo-1, has all the links that I talked about, and love seeing everyone on the call. Thank you.